Hi, this video is on voltage dividers, and this is part 2 of the series. So in this particular video, we want to charge a cell phone, and all we have is a 9-volt battery. So what we want to do is use a voltage divider in order to do this, because you can't directly connect a 9-volt battery to the cell phone, because the cell phone, only the input can only be 1.5 volts and 500 milliamps. So we're going to use a circuit similar to this one to do that. So automatically we know that the total current running through this has to be 500 milliamps or zero point 0.5 amps. We also know that the voltage across this load has to be 1.5 volts, because this is where we're going to connect our leads to in order to get the voltage for the cell phone. So this here has to be 1.5 volts. So that's what we know so far. And we could also solve for the total resistance, and that'll come in handy later on. So in order to solve for that, what we're going to need is this formula, which is the current is equal to the voltage divided by the resistance. And we want the total resistance, so the total resistance is going to be equal to the voltage of the supply divided by the current. Now the voltage of the supply is 9 volts, and the current is 0.5 amps, and that's going to be equal to 18 ohms. So the total resistance of the circuit has to be 18 ohms in order to get that the current. So now we want to solve for the actual resistance on the load. We want to know, well, what is this resistance here? We know the current going through it, and we know the voltage across it. So we know everything we need in order to get this resistance. So let's go ahead and solve for that. And again, we're going to manipulate this formula. This I equals the voltage divided by the resistance. And we're solving for the resistance on the load. So what we're going to need is the resistance on the load and the voltage on the load. So it's going to be the resistance of the load is equal to the voltage on the load divided by the current running through it. And the current is always going to be the same. So the voltage on the load, we know what it is because that was given. It's 1.5 volts divided by the current running through it, when that doesn't change, which is 0.5 amps. So that's just going to be equal to 3 ohms. And you know that's true because this is just 1.5, so you're just going to multiply this by 2, and that'll give you the 3 ohms. So that's the resistance on the load. So this new circuit's going to look like this. So you're going to have your power supply. Now we know that that has 9 volts on it. We're going to have some resistor here and some resistor here. Now this is the resistor with the load on it, so we just figured out that this is 3 ohms. And the voltage across here is going to be equal to 1.5 volts. That's equal to the voltage of the load. So automatically we know that the voltage on, let's call this R1, we know that the voltage of R1 has to be equal to the remainder of the voltage from here to here. Since you have 9 volts from here to here, you know that this one right here is just going to be the total voltage minus whatever voltage is here, because it's just, these two have to add up to 9 volts. So this is just going to be 7.5 volts. Or you could just say the voltage of the supply minus the voltage of the load is going to be equal to the 7.5, and then you just put in the 9 minus 1.5, and that should give you the 7.5 volts. And if you wanted to solve for that as well. But so now we know what the resistance is here. And earlier we solved for the total resistance. So it's 18 ohms as a total resistance. And since we know that this is 3 ohms, well then this R1 has to be 15 ohms. So the completed circuit is going to look like this. You're going to have R1, which is equal to 15 ohms. Then you're going to have the resistance of the load, and that's going to be equal to 3 ohms. And there's your 9 volt supply. So this circuit right here will give you the voltage that you need right here. And it'll also give you the current that you need to go through it. So That's how you would solve this problem, and that's how, if you wanted to charge your cell phone using a 9-volt battery and you wanted to make a voltage divider in order to do it, that's how you do it. So, oh, by the way, I don't really recommend you actually do this to charge your cell phone. I mean, you'd want to add some other components in here to make sure that things don't surge, in case if the battery gets too hot, stuff like that, because that'll change the resistance and a few other things. But that's for later stuff. Anyhow, I really hope you liked the video. If you did, please like it and subscribe so you can check out the next videos that are coming out. So thank you very much for watching, and I hope you have good luck in your classes.